After getting your robot to drive straight, obviously the next goal is to get it to turn. There's a couple different types of turns, but the two main ones that we're going to talk about are your pivot turn, where one tire remains still and the other one moves. This can also be called a swing turn. The other one is a point turn, which can also be called a spin turn, and that's where both tires move, but one goes one direction and the other goes the other direction. And the point that they spin around should be right between the two tires. So one causes the robot to move quite a bit more and can sometimes swing into other things depending on how close things are. The other one is a little bit more controlled and limited in the movement, which can be important sometimes depending on what you have around your robot on the board. The first one we're actually going to try out is the swing turn. It's a little bit easier to program, a little bit more straightforward. So I'm just going to make a new project for right now. And we'll go ahead and save it as test turn. And basically all we need is just one motor block. We're not turning both motors, we're turning just the one for that swing or pivot turn. And really that's actually it. Now to determine how far it turns, that's a little bit more complex, and we'll talk about that in a minute or two. So now we just connect the robot. So once again, the micro USB in the back, and turn them on. Make sure that it's connected to my actual computer through the USB in the back. So now we can tell it to actually download and then give it a try. So if we navigate through here, then we can find the program and we can run it. And nothing's happening. Why? Oh, I know what it is. So if we go back and we look, so we can see our port view here. We have motors in B and C, and this is moving port D, so that's not helpful. So we'll try that. We'll try downloading it again. And we'll run it again. Oh, just kidding. That was test drive. Make sure you're running the right program. Test turn. There we go. So that was actually pretty good. That was about 90 degrees. Really, really close. Now if we look at our actual program here, this is set to 1 full rotation. If we switch this to degrees, that's 360 degrees. And you might be wondering, well, if this is 360, then why did I just say 90? So when you're programming for turns, you have to keep in mind that the degrees that you're turning in the program is the degrees of the tire itself. So 360 would be 1 full rotation of the tire, not necessarily 1 full rotation of the robot. Now you can calculate how much to rotate this to turn here, but it's not a magical number. I can't just give you the number. It's going to depend on a couple of different things. It's going to depend partly on the size of your tire, but also the distance between the tires. Because just like driving straight and measuring, we could measure the circumference of this turn to figure out about how far that would be, and then try to. So if we took string and hopefully not yarn, because I've already mentioned that yarn is bad, but we could try to figure out if that's to here, to there, to there, etc. We could try to figure out about what this distance would be. You can see this is not a super accurate way of doing this, is it? So if I were to measure this, I would get an approximation, but really just doing a little bit of math would work a lot better. But I have shown how to turn. The next thing, if you want to really understand turning well, which you should because you're going to need a lot, is to get out some tape again. Alright? So the goal here would be to figure out how to get it to go 90 degrees, and then 180 degrees, 270, and then a full 360 back around where it started. If you can get this, you can start to understand turns quite a bit better and how it works with the robot you've built. Now, the most logical way of doing this is really to figure out the 90, because if you can figure out the 90, you can multiply that by 2, and you should get pretty close to 180. Multiply it by 3 to get 270, and all the way around to get 360. Mine at 360 degrees was really close, so I'm going to try to bring this down a little bit, maybe down to 345. And I'm going to move over to this panel here, this flow control, which we haven't talked about yet. I'm going to drop that in there and have it wait for 1 second, so that way I can see where it pauses to know whether or not it worked. So now I can drag in another, still on B by default because that's what I set the last one to. And if I double 345, that should be just shy of 700, so that should be 690. And I could put in, let's close that. I could put in another weight block and try for the third one and the fourth one and see what happens. I think I'm going to try this before moving on. Let's move up to the right program. Tell it to run. Make sure that this looks aligned properly. Oh, well, let's try that again. We'll try it down here. Alright, that was pretty close. So it was still a little too much here, and then it magnified that and turned a little too much here. So it's hard to see a little bit, but that's about how far off it was on that. If I instead started here, you can probably see a little better to see how far off it was. So based on where this started, it wasn't quite where I want it to be. Let's try maybe right about there. Alright. There you go. So you can see it's not quite lined up. It's a little bit off. If I move this down to about there, it's a bit off. It's not quite, but it's really close. So maybe if I tried to bring it down to 330, that might be a little better. It's going to differ on your robot depending on how far apart your wheels are and the size of your wheels, but that gives you a rough idea. So the goal for you at this point to really understand your robot and how to get these turns to work right, get it to do 90 really well, get it to do the 180, 270, and a full 360.